next, then we're going to talk about transmutation reactions, and we've gone over what the different types of particles are. We went over what an alpha particle was, we went over what a beta particle was, but before we start this, I want you to understand that this is a proton, a 1,1p, a neutron is a 1,0n, and an electron is a 0, -1e, which is a beta particle, and a positron, which is what we'll discuss later, is basically an electron that's been thrown into the nucleus, and now it's positive. So it's a 0 + 1 electron, which is kind of crazy, right? And then all of these reactions are still going to follow the law of conservation of mass. So when we do these, the total from the reactants is going to equal the total from the products, the mass number and the atomic number. So when you look at these, the first one is called alpha bombardment. And what does that mean? That means the alpha particle is in the reactants. So it's going to be like a uranium-235, which the atomic number is 92, okay, and then plus an alpha particle. Well, all you're doing is adding the top numbers, so it's 235 plus 4 equals what? 239. 92 plus 2 equals 94. And then you have to look on the periodic table and see which element is 94. It's the smelliest element on the periodic table, Pu, or plutonium. All right, and so that shows you that the total of the reactants is going to equal the total of the products, because if you add that up, it's 239 and 94, and that equals 239 and 94. It's not always going to be this simple. You might have two things, so that's why I'm warning you with that. Okay, electron capture is our second one, and electron capture is when a beta particle is in the reactants. So you have a 235-92 uranium plus a beta particle. So what is that going to make? Well, you do the adding, so it's 235 plus 0 is 235. 92 plus -1 is going to make 91. Okay, and then you look up on the periodic table what 91 is. It's protactinium, Pa, right? And so you can see that the total from the reactants equals the total from the products. The next type is called alpha decay. And you're going to see alpha decay and beta decay are the two most popular that you're going to see all the time, because in radioactivity, most of the time it's giving off particles. And so this is what happens when things give off particles. You got a 235-92 uranium. The alpha particle is in the products now, so it's giving it off. So you still have to have the right, mass equaling the product's mass. So really, instead of this arrow, it's almost like an equal sign, right? So you have 235-92, so it's blank plus 4 equals 235. So what's that? 231 plus 4 equals 235. Blank plus 2 equals 92. That's 90. And then you look up what 90 is in the periodic table. It's one of our Marvel superhero elements, thorium, okay? And what you'll see is you still have to have the law of conservation of mass. So 235-92 equals 235-92 when you add up these and add up that. It equals each other. Okay, the last one here is beta decay, and that is when a beta particle is in the products. So now this one kind of blows people's mind because you're adding a negative number. So it's 235 because the top number is 0, and then it's 93. You look up 93, and it's neptunium, Np. All right? And so you have 235-93 neptunium plus -1, and you get that. All right? And so, the total from the reactants equals the total from the products. Okay? And then the last one I forgot about is a positron emission. So this is when you have a positron that's in the products. Okay? And so it still has to match up. So you've got 235. And then you've got blank plus 1 equals 92. So it's just 91 plus 1 equals 92. Well, 91 is Pa again. Each time you have to label what the element is. All right, and then the last thing is this. If you have a coefficient in front of a number like 3 and then a neutron, that's telling you have 3 neutrons. So that's a 3, 0 on your number count. All right, so that's how we do transmutation reactions.